Good afternoon, children. In last class, we discussed about theorem based on property of the tangents, that the tangents drawn from an external point to the given circle. And we proved the theorem with respect to that, and we solved few questions related to tangents and the theorem based on congruency or by using similarity of the triangles. We have discussed that part. Today we will discuss few more means 2 to 3 questions that are based on again tangent property of the circle and using the properties of the theorem that we have already discussed, right? In last class, few questions we have solved, and that type of questions most probably will be asked in your examinations for 2 or 3 marks, right? Be perfect with the types of questions that are given in your exercise so that it should be helpful for you to solve other questions. And with respect to that, one more thing, the thing that you have to do is you have to practice the appeared questions, so far appeared questions in your examinations, right? As much as practice you will do, you will be perfect in solving, no doubt in that. If you not practice, definitely it will be a difficult part for you. So keep doing the practice on the topics, right? And today we will discuss 2 to 3 questions so that we can wind up this lesson, and it will be helpful for you to practice it more, right? Here I have selected again a question from your exercise. Here in the question, you are given with a figure from your exercise only I have taken. In this question, your work is first you have to understand the figure, then we can solve it. It will be more easier for you to solve. Here in the figure they have given xy and x dash y dash are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB is equal to 90 degree. This is your question. We have to prove here angle AOB. First thing we will mark where this angle AOB is. Here, if you see the figure, your angle AOB is here. We have to prove this angle as 90 degree. Yes, to get this angle, we have to study the figure here. If you observe the figure for a given circle, right? For a given circle, OP and OQ are the tangents. Here, OP and OQ are the radii and AP and AC is the tangents drawn from external point A, right? Because we have to use the theorem which we have learned so far. And if B is the external point, then BC and BQ are the tangents drawn from external point. According to the property, they are going to be equal. That means AP will be equal to AC and BC will be equal to BQ. Another thing that we are going to use here, OP is the radius, OC is the radius and OQ is the radius of the same circle. That means all these three radii will be equal. One by one we are going to use them so that we can prove the needed one. Let the tangent AB touches the circle at C. What we have to take here? We have to take with point of contact C intersecting XY at A and X dash Y dash at B. Right? For this reason, what we are going to take, AB is passing through C. Our work is join CO, because at the point of contact the radius drawn or the perpendicular drawn from the center to the point of contact is 90 degree, right? Why we are going to take this one? Because it will help you to prove here. At this point, this will be the point of contact and angles will be 90 degrees. Here, if you proceed, see here, if you take the first part of the problem, if you consider triangle OPA and triangle OCA, you can observe this OPA as well as OCA. If you observe these two triangles, here we can use the properties. Any of the property you can apply, either RHS theorem you can apply or you can go for any of the congruency, right? Which will be more easier, we will go for that. Here for us, yes, postulate will be more helpful. In the given figure, OP is equal to OC because it is the radius of the same circle, right? Then next one, AP is equal to, here having here AP is equal to AC. Reason is in the image you can see that AP is equal to AC because tangents drawn from an external point to the given circle, they are going to be equal. Then one more thing we are going to take, AO. AO side is common side. This is common side for both the triangles. Therefore, we have used here yes postulate. Side, congruency we can tell. We have used SSS congruency. Based on that SSS congruency, we have arrived to the proof here that triangle OPA as well as triangle OCA are congruent. Once they are congruent, definitely all its angles are going to be equal. To prove the next part, we need the very important part here. Once we use congruency, we can write angle POA, this angle is equal to angle AOC or which angle POA is equal to AOC or COE. Both these angles are equal. For identification, I am marking this. You can easily identify. These triangles are going to be equal. Similarly, if you come for the next part of the figure, in the figure, you have to consider here BQO and BOC. Here, again in triangle, yes, in triangle BQO and BCO, we can write BQ is equal to BC because tangents drawn from external points, right? Tangents drawn from external point, and here CO is equal to CQ. CO is equal to OQ because the radii of the same circle. Then this OB is common side. Again we are using SSS congruency. Because of SSS congruency, you can write triangle OQB is similar to or congruent to OCB. Once you prove that they are congruent, then definitely they are going to be similar angles. They are congruent as well as similar. Once they are congruent, they are going to be similar. Based on that property, we are going to take here. Once they are congruent, we can directly write all its angles are, corresponding angles are equal and its corresponding sides are also equal. Here we have proved this angle. This angle and these angles are equal. Just for identification, I am naming them as angle Y and angle Y. Now, if you observe here in the figure, POQ is a straight line, isn't it? We can see from the figure POQ is a straight line, and this straight line is having angles here. If you see, 4 different angles are through the point O, which is on the line PQ. Therefore, we already know the sum of all the angles on a straight line is going to be 180, isn't it? If it is 180, how we have to prove these two is going to be 90? Just simply here, if you see in the figure, POQ is a diameter here. POQ is a diameter and the sum of angle POQ, the sum of angle POQ is 180 degree, and this POQ includes angle POA. If you just see the figure, POA plus angle COA plus COB plus QOB is equal to 180, isn't it? To make it more simpler, better I will write here angle POA is, I have taken X there, COA I have taken X, COB Y, QOB is Y. If you go with this, it will be more easier for you. Then you got X plus X, 2X plus 2Y is equal to 180, isn't it? Or you can substitute. These angles are equal. In place of POA, you can substitute it as COA. And in place of COB, you can substitute. In place of QOB, you can again substitute COB. COB 2 times. COA 2 times. If we take 2 common here, we'll get with X plus Y is equal to 180. And if you divide, you will get X plus Y is equal to 90 degrees. And what this X and angle Y? Angle X is COA, isn't it? Angle X is COA, angle Y is COB, and we proved it as 90 degree. And in the figure, if you observe your angles, POA, this angle, here it is. If I remove all these things, COA, right, plus COB, these two angles. If you add these two angles, you are going to get the angle AOB. It is nothing but angle AOB, which is asked for. They have asked us to prove this, isn't it? This is your proof. Angle AOB is 90 degree. Then coming for the similar one more question. Here, prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. Here we have to prove that angle formed or drawn from the angle between the two tangents drawn from an external point means this angle, that means angle APB and angle AOB. If you add these two angles, the sum should be equal to 180 degree. That we have to prove. Yes, here it is given. What to prove? APB plus BOA is equal to 180 degree. To prove this one, it is given the tangents drawn from an external point. That means we are going to take point P as the external point, and from point P we are drawing the tangents PB as well as PA to the circle with center O. Then join AO and OB. Here we already know at the point of contact the angle is going to be 90 degrees. Therefore the sum of these two angles will be 180. But we have to prove these two angles are, the sum of these two angles are 180 here. Right? To prove this one, if you observe the figure, let me remove this. If you observe the figure, this is your angle APB or BPA and angle AOB or BO. In any order you can do. To prove this one, we are going to write angle A is 90 degree and angle B is also 90 degree because angle at point of contact. Isn't it? Point of contact. This is one thing. Here also angle at point of contact. Then if you observe the figure AOBP, if you observe the figure AOBP, it's a quadrilateral. In quadrilateral, here OA PB, angle OAP plus angle APB plus angle PBO plus angle AOB is equal to 360. It is by property of the quadrilaterals, the sum of all the four angles will be, interior angles will be 360. And we already know angle OAP as 90, APB we don't know, write as it is, PBO is 90 degree by property and BOA we don't write as 360. Next 90 plus 90 it will become 180. If you transpose your 180 to another side, 360 minus 180 to become. Right? If you do 360 minus 180, your answer is going to be 180 only. Therefore, directly you can take APB plus BOA is equal to 360 minus 180 will give you this result. Angle APB plus BOA is equal to 180 degree. Hence it is proved. Right? This is about the solution about the given question. Your next question is again a similar question where you are going to prove a parallelogram circumscribing a circle is a rhombus. Whenever you are going to circumscribe a circle, definitely that quadrilateral should be a rhombus. That we have to prove. For this one, we will take a quadrilateral, and here especially the quadrilateral is a parallelogram. Okay? According to the given, the quadrilateral is a parallelogram, and if you draw a circle, circumscribing means the circle will be inside that parallelogram. Here it is the given figure. We have to prove this parallelogram is a rhombus because rhombus is a special case of parallelograms. Right? Here we have to prove that ABCD is a rhombus. Means what we have to prove? If you want to prove ABCD is a rhombus, then you have to prove AB is equal to BC is equal to CD is equal to CD is equal to DA. That all the four sides are equal. That to prove. to prove is this one, and given is AB is equal to CD and AD is equal to BC, because they have given it is a parallelogram, means opposite sides are equal and parallel because of the parallelogram property. Let's see how to prove this one. Prove that parallelogram circumscribing a circle is a rhombus. Given ABCD is a parallelogram circumscribing a circle. What we have to prove, I have already written that AB is equal to BC is equal to CD is equal to DA. Proof ABCD is a parallelogram. Based on that condition only, if ABCD is a parallelogram, its opposite sides are going to be equal. That we have to mention here. This one. AB is equal to CD and BC is equal to AD. Opposite sides of parallelograms, as they are going to be equal. And one more thing, as we know, circle is circumscribing. Circumscribing means it is touching at one to all the four sides of the parallelogram, right? Then if you see the figure here, see it, point P, point Q, point R and point S. AB will become the tangent which is passing through point P. BC will become the tangent which is passing through point Q. DC will become the tangent which is passing through point R, and AD will become the tangent which is passing at point C. Based on this, what we can write? If B is the external point, C is the external point, D is the external point and A is the external point, that means I can use the property here, the tangents drawn from an external point are equal. Based on that, I can write here AS is equal to AP, BP is equal to BQ, isn't it? CQ is equal to CR and DR is equal to DS. Because the tangents drawn from external points are equal. Right? Here, see here how I can write. As I said, we can write here DR is equal to DS, AP is equal to AS, BP is equal to BQ and CR is equal to CQ. These four equations we are going to add. LHS, all the LHS at one side and all the RHS at another side we are going to add. After adding, we are going to get this one. DR plus CR plus BP plus AP is equal to DS plus CQ plus BQ plus AS. If you group them so that we can get a line, BP plus AP, here it is. If you group them, definitely we can easily replace. Here by given, we can write BP plus AP, DR plus CR here, and DS plus AS plus CQ plus BQ. By figure, BP plus AP is nothing but AB, DR plus CR is nothing but CD, DS plus AS will be nothing but by figure, it will be representing AD, and CQ plus BQ is nothing but here BC. Now as it is a parallelogram, as it is given, we have already know that AB is equal to CD, right? Isn't it? We have written here also. AB is equal to CD means in place of this CD, you can replace it as AB. AD plus BC. In place of BC, you can write it as AD again, because opposite sides are equal. Then we get 2 times of AB is equal to 2 times of AD, or if you replace by AD by BC, then you will get 2 times of BC. 2 will get cancelled. You will get with AB is equal to AD, and we already know AD is equal to BC. This implies we can write AB is equal to BC is equal to CD is equal to AD. All the four sides are equal. If all the four sides are equal in a given parallelogram, then we can name that parallelogram, we can write it as a rhombus, because it's a special case of a parallelogram where all the four sides are equal. Hence we have proved a given parallelogram, if it is circumscribing a circle, definitely that parallelogram is a rhombus. This is all about the tangent properties of the circles. And in this chapter, you should be very perfect with solving these kind of questions, and be perfect with the theorem, so that you should not lose any of the marks, right? Here, so far we have discussed about the circles, right? We have seen properties, theorems, and how to solve the problems. I have especially selected your textbook questions only. Your work is you have to go for as many as possible other questions which are appeared so far based on these circles, so that it will be helpful for you to solve the questions which will come in your examinations. You should be perfect with multiple choice, 1 mark, 2 marks, and 3 marks questions. Be perfect with the theories, right? Till then, your work is to practice problems. Then I will share some practice questions based on the lessons, and practice them also, right? Stay home and stay safe. Thank you.